Okay. Okay, sir.
And hopefully tomorrow I will post another lecture, 1 or 2. Okay.
Sir, does complex analysis include quaternions?
No, quaternions are a generalization of complex analysis. Quaternions don't have as much structure as complex analysis, but so as you know that there are only 4 algebras which include where you can define division, right? So the first one is the real numbers. The second one, so the real numbers are commutative. It's ordered, commutative, and associative. And then comes the complex numbers, which are, of course, not ordered. They're still commutative and associative. Quaternions, on the other hand, are not ordered and they're not commutative, but they're associative. Okay? And the octonions are not ordered, they're not commutative, and they're not associative. And the next thing, is not commutative. After the octonion, the other algebra is not commutative, sorry, not ordered, not commutative, not associative, and does not exist. Okay. So that's a joke. That Dominic Joyce. I don't know if you've ever heard of Dominic Joyce. He's a very famous mathematician from Oxford.
Which field of math cover quaternions?
Quaternions are essentially, I would say, well, just as complex analysis, it's its own field. Quaternions are essentially a generalization of complex numbers. You have, instead of 1 complex unit, you have 3 complex units called I, J, and K. And each of them, I squared, J squared, and K squared, each of them satisfy the same thing as the complex numbers. But there are additional structures that I and J, I times J does not commute, is not equals to J times I. Instead, I times J is K. And J times K is I, and K times I is J. Okay, so they are not commutative. Okay, but they are associative. So if you have I, J, K, that is equals to I, J, K. Okay. So this is very, very very useful. Quaternions are extremely useful because it turns out that the real numbers, quaternions can be used to model rotations in 3 dimensions very, very efficiently. And quaternions are used very widely in the field of games, of computer games, because in computer games, if you're playing like a shoot 'em up game, it's like a first person shooter, yeah. Then you have to do a lot of rotations and stuff like that, and to do them with matrices is a lot harder. It's more computationally intensive, whereas with quaternions you can do it very easily.